Thank you so very much for joining us. You can have your seats. And next, I would like to quickly invite to the podium my very good friend. As a matter of fact, is an individual who we shared some time downstairs, and you could sense the passion with which he shared all he had, and that is no other person than Ebatarhe Osiobe, Hydrocarbon Accounting Field Engineer at Heritage Energy Operational Services Limited. Please put your hands together for him. Okay, if with the kind permission of the chair, please could you sit on the second seat? Yes, there's a reason why I reserved this seat, because I want it to be gender balanced, and that is going to be inviting Yewande Tuyi-Aroge from the Green Energy International Limited as she joins the panel, a seasoned production chemist with extensive experience in hydrocarbon analysis. Madam, you will take the, that's why I reserved that seat for you, so that we have energy balance, and then that way it cuts across in that regard. So at this point, I would like to invite the last but not the least, and that's Engineer Bolahon Lawal, the MDC of Automations Limited, as he comes up and joins them on the podium. As you can see, ladies and gentlemen, 2 men, 1 female, 2 men, 1 female. You see that it is a quadratic equation, well balanced. If you are going to explore the x, the y here, you will see the coefficient is well balanced, less than 2 or 1. And so this is highly, well, let me just seize myself. Madam, I'm handing over to you before I think I'm in the lecture hall at the moment. So within the next 1 hour, more or less, we will do the integration as we discussed. And then if you need my help, I'll just be sitting down here. Thank you very much. Please put your hands together for the panel.
Thank you very much, our dear MC. It's a pleasure to be here this afternoon. I've already been introduced. We're going to be speaking on the topic hydrocarbon accounting and management. Following up from the panel session we had this morning/afternoon, we touched on a couple of interesting topics: technology, the role of people in proper hydrocarbon accounting, the issues with crude theft, and also measurement. And we're going to do a deep dive this afternoon with our seasoned experts on the topic, my colleagues. And I will not take too much of our time because we're running behind time already. I'm going to hand over to Engineer Wokoma, who's going to speak to us about accounting for Aradel Refinery feeds and products from a measurement perspective. Over to you, sir.
Good afternoon. I beg to continue with the existing protocol in place. So this afternoon, I will take on Aradel Refinery's crude feed and products measurement, basically. So a brief update about Aradel Refinery. Aradel Refinery is a subsidiary of NDEP. We recently rebranded as Aradel Holdings. And in Aradel Holdings, we have basically 3 companies in the operations sector: the flow station, the gas plant, and the refinery. So as we can see, Aradel is a truly integrated company. We produce our oil from our wells. We take it to the flow station. In the flow station, we have different outlets depending on what is available on ground. We can go to the TMP. We have also batch operations that we carry out, and we also carry out refinery operations, but I will focus mainly on the refinery operations. So our story. In 2010, Aradel Refinery started with a mini refinery, 1,000 barrels per day. It was producing only AGO, basically for the in-plant need and other general services. In 2020, Aradel Refinery expanded with additional 2 trains, 2 by 5,000 barrels per day trains. Currently, we have a total capacity of 11,000 barrels per day. And our products basically are naphtha, DPK, kerosene, AGO diesel, and fuel oils. With the recent deregulation of the sector, we are going to go further into the PMS production. Just to mention, I'm not sure whether the slides are being shown, but it's fine. So the train 1, train 2, and train 3, as I said. Okay, so the trains 1, 2, and 3, as I mentioned, from 2022 are available and they are running. Currently, train 1 is slightly on and off because the train was designed to use heavy crude with API 3334. And the well producing the heavy crude recently ran out. So we are making arrangements to get crude from outside. But for trains 2 and 3, the crude we have in the field is okay for trains 2 and 3, API 4041. And currently those two trains are running at between 60 and 85% capacity. So now going further into the metering aspect, because we increased from 1,000 barrels per day to 11,000 barrels per day, definitely this will affect our metering and our measurements. Before now, we take only 1,000 barrels of crude feed daily, but at the moment we take between 8 and 11,000 daily. So this brought up additional challenges for metering. And also, before now, we had only one product, AGO, which we are metering. But now, based on the regulations, each product have to be metered from each train. So it's not even a matter of using one meter to meter AGO from both trains. So this significantly increased our metering requirements from about 10 meters to now over 40 meters in the refinery. So also our loading activities. Before now, we had only a small loading gantry with 2 loading arms. At the moment, we just commissioned a bigger gantry with 16 loading arms. And also based on the requirements, fiscalization, selling products to customers, we have to put meters on each loading arms. And we are dispensing with all the 16 loading arms for this refinery. So because of time, I will just round up briefly. So I have taken the upstream, the feed, and the export through the loading gantries and so on. Also, in our loading facilities, because of the complexity of loading several trucks at the same time, recently we brought in a new loading system, automated loading system, which we just input our requirements and the meters will load the required liters as the truck compartment can hold. So basically, I think I will stop here, and as we go on, I will be ready to take further questions. Thank you.
Thank you very much, Engineer Wokoma. I would like to ask our audience to please note your questions. We will come to them. We'll take the Q&A as we go along. I will now invite Yewande. Yewande, maybe you want to stand so that you can see your slides. It makes it more comfortable for you to present. So Yewande will be speaking to us about effective chemical treatment program for accurate hydrocarbon accounting, a field experience.
Good afternoon, everyone. I hope you're all having a wonderful afternoon. It's such a great pleasure to be here today alongside other distinguished individuals who have shared and will be sharing their valuable insights in the discussions. I will not also fail to recognize the keynote speakers who have brought great wealth of knowledge and expertise to this gathering. distinguished ladies and gentlemen, all protocols duly observed. Today, I'll be speaking on effective chemical treatment program for accurate hydrocarbon accounting. But before I go into that, I would like to say a brief about me. My name is Yewande Tuyi-Aroge, as mentioned. I am an industrial chemist, a chemical engineer in view with few years of experience in hydrocarbon analysis. I also have a background in chemical evaluation and research at the Research Directorate of NAFDAC. I think it's also important to state that I'm going to be speaking for myself and not on behalf of my company. And without further ado, I would like to delve straight into my presentation. Imagine a world where every single drop of oil and gas produced is accounted for with precision, ensuring that not a single reserve is wasted. Within this process lies challenges that are critical, such as accurate determination of water cuts and flow assurance issues. These seemingly small details can lead to monumental implications on economic efficiency and environmental stewardship. Also, I would like to mention a key element in the optimization of hydrocarbon accounting, and that is the installation or use of inflow control devices during smart well completions for the regulation of early water breakout from the reservoir. I'm going to speak more on that later in my presentation, but before that, I'd like to unravel the connection or the interplay between accurate hydrocarbon accounting and effective chemical treatment program using my field experience. This particular field over the years have experienced certain operational challenges, taking roots from the nature of the producing wells. Some of the wells have high emulsion. And as we all know that as emulsion moves along the pipeline, the water droplets in the oil phase tend to enhance the wax appearance temperature. And then the wax begins to precipitate, aggregate, and eventually deposit on the inner surface of the pipelines. And over time, as this wax begins to deposit and accumulate, they reduce the flow capacity of the pipeline. That was not, please, can you go back to the previous slide? I'm still on the previous slide, please. That was not the only challenge that was faced in this particular oil field. Other operational challenges like productivity declines in wells, oil water separation concerns. And here is a chart showing the transportation of the crude from the point of storage through pipelines to the point of export. And as we can see on this chart that initially there was a very low flow rate in the pipeline, there was a very flow rate, and that prompted a pigging operation at this point. The pigging operation was able to solve the problem temporarily, but over time, as wax deposits began to build up, the flow rates declined again, and the result of that is that a significant portion of the crude intended for exports remained trapped in the line in form of paraffin wax, as you can see from that diagram. So these highlighted challenges resulted to a need, an urgent need to mitigate the problem. And that's why we opted for implementing an effective chemical treatment program. Next slide, please. Implementing an effective chemical treatment program. The procedure was initiated by a great deal of research on the right chemical to use for the implementation. And initially, we used industrial grade silane for the flushing of the line in order to get it cleaned and prepared for the crude treatment. After that was sourcing for accredited and experienced chemical companies to help in the implementation of the program. The next stage is the data collection. During this stage, samples from the upstream and downstream positions of the facility were collected for proper analysis, and characterization tests were carried out on these crude samples to understand the nature of the crude. And it was discovered that These crude samples contained natural emulsifiers, 3 major ones: paraffin, asphaltenes, and naphthanates. But it had a high percentage of paraffin, therefore it was said to be paraffin stabilized. Other parameters were also collected, such as the production rates, the operating temperatures and pressures, and etc. The next stage was analysis and design. In the formulation of any chemical, 2 things are important, and that is the intermediates, which can also be regarded as the active components, and then the carrier solvents. In the case of this field, 2 chemicals were focused on, and that's the point depressants and the demulsifiers, because of the nature of the crude. So the chemicals were formulated to fit the crude type. They were formulated in such a way that the molecular structure of the intermediate fit properly into the chemistry of the crude. And also, this was done in order to actually know exactly what to do and not to waste time during the monitoring and optimization stage. Before that stage is the implementation stage, where an array of chemical kits designed to meet the peculiarities and specifications of the crude were brought to the laboratory for bottle testing in accordance with the ASTM method for water cuts determination and BS&W analysis. So this was done in order to have a perfect example, in order to actually have a perfect example of, or to also, actually in this stage, the implementation stage is just all about doing everything that you have to do to ensure a good chemical treatment in your crude. After the implementation stage was the monitoring and the optimization stage. In this stage, we focused mainly on the optimization of the injection rates, where the injection rates were calculated based on the ppm used during the bottle testing, and the concentration was continuously optimized and monitored until an optimum performance was reached at a very low ppm, and that contributed significantly to the economic efficiency and the quality assurance of the crude. After this stage, we moved on to the validation and the verification. Validation checks were carried out to verify our results, and we ensured to carry out replicate analysis in order to ascertain the precision and the accuracy of the process, of the chemical treatment process. And after this stage, we did all this in order to build confidence in the data generated from the chemical treatment process. And then we handed over the entire operation to the operations and maintenance team. Next slide, please. Results and inference. From what we can see from the entire implementation of the chemical treatment, we are able to see that when the wells, here is a picture showing that remulsification occurred as a result of over-injection of the chemical. And that's why a great deal of work was done during the design and analysis stage, such that we understood the nature of the crude, we got our formulation right, and it gave us our desired results from all indications. Now, this table is showing the emulsifier, which performed optimum at 20 ppm for a well that has a very high emulsion, as high as 25%, and it was able to beat it down to about 0.08%. And also for the point depressants, even for the emulsifier at that same temperature, for the commingled sample in the auto sampler, we got a point temperature of about -9 degrees C, something that was giving 25 degrees C initially. So we got our desired results because we followed due process. Next slide. And next slide, please. We got our desired results from because we followed due process, and that's brought about enhanced hydrocarbon recovery, increased production efficiency, improved data accuracy for precise hydrocarbon accounting, compliance and environmental benefits, cost savings, flow assurance, and valuable insights for future applications. Ladies and gentlemen, I would like to recommend a game-changing technique for the optimization and accurate accounting of hydrocarbon, and that is first downhole emulsion breaking. I want to explain this using the gas slipstreams for gas slipstream wells. And in this case, chemicals are injected at the surface of the well and at the surface level using a pneumatic dosing pump. And this chemical is carried with the aid of the gas into the annulus in order to mix well with the well fluids in the reservoir to destabilize the emulsion. Another point is the nanotechnology of demulsifier. That is the use of nano demulsifiers by leveraging nanotechnology. A case study is the Alfaya oil field, which I cannot start talking about that now as I'm really out of time. Then the next point is the installation of inflow control devices during smart well completions, which I mentioned earlier. This is able to regulate the early outbreak of water from the reservoir. I believe if we can leverage on the power of these three recommendations, and of course, an effective chemical treatment program, we do not only safeguard the sustainability of our industry, but we also contribute significantly to a responsible and an efficient energy future. So this will be the end of my presentation. Thank you for your attention.
Thank you very much, Yewande. I know you were pressed for time and trying to, pack all that information into the very short time. I'm sure that when we take the questions, I'm going to take a few questions now before we call up the next set of speakers. I think Engineer Wokoma has essentially walked us through how Aradel Refinery have tried to adapt from a 1,000 barrel per day refinery to about 11,000 barrels per day, with changing regulatory requirements, measurements of metering of their AGO, as well as the other crude cuts. And Yewande has just explained to us how with chemical treatment, we can optimize our flow rates and also our production. So I'll take a pause now. I don't know if we have some questions before we call on the next speaker. Okay, we have one MC. Dear MC, thank you.
Thank you.
Good afternoon, everyone. My name is Victor Tao. I'm actually from Houston. I'm actually was sent to attend this NIMED conference, so I'm here for the first time. The reason I was asked to come was to promote the nanotech technology, which Yewande had just talked about. So the question I have, we go to the Aradel gentleman, that when you move from 1,000 barrels, you say, to 11,000 barrels, there have been an increase in the usage of positive displacement meters, Coriolis, and all of that. The question I have is, how have the increase of the use of these meters, how have you managed the maintenance going forward with this huge demand of the 11,000 barrels you do? The second question had to do with part of what Yewande talked about, which I'm really proud to say, and I've been taking pictures to show some of my counterparts in the US there, that Nigeria is actually looking forward to the implementation of what they call the chemical enhancing technology. So while digital technology is going at the other end, the world is also increasing and chemical enhancing technologies. From everything that we do, so it's beginning to change the oil and gas industry, where I have been leading some of the introduction to even Shell. We did a test for Shell last year where we were introducing the nanotech technology. Right now, we're doing the same thing for Chevron as well. So there has to be a way to begin to create a pathway for chemicals like nanotech. And it's doing a lot in the United States that I know, and it's easy for everyone to take notice of. The other thing I want to say, it's more of a suggestion, with the institutions here, maybe NU, ROPC, if I'm right about that, and all the governmental organizations here, would like to know what it takes to manage, or what are the issues associated with the various LAC units in Nigeria, so that once I'm able to know that, we want to begin to find a way to come and present to NRPC, for example. That's all.
Thank you, sir.
Okay. Because of time, I left out some issues, but I will take 1 minute to go through them. So basically, our challenges, we have challenges, definitely. Moving from 1,000 to 11,000, there's no way we won't meet challenges. So the first challenge we meet is because of regulatory guidelines, we need to do recertification of all our meters. Before now, we do it 3 monthly. Recently, the regulators brought it down to 2 weeks or 1 month, but we are still discussing on how we can, maybe because we have over 40, 50 meters to recertify every 2 weeks, 50 meters. It's a challenge, and it's not just bringing in vendors to recertify. You have to go through the process, application, approval, and so on. Another thing we are doing is we try to minimize process offsets, because as long as your process is running in equilibrium, you don't have much challenges in metering. But once you start having offsets and gas and liquid mixing and giving a kind of inconsistent flow rates and flows, then you start to have challenges in metering also. So basically, we do those things. And in the refinery, as we all know, we have very high temperatures, 600, 660 degrees Fahrenheit. And to manage instrumentation at that temperature is not that easy. You have coking and some other issues. But let me go straight to the answering the question. So basically, we have certified vendors who we have contracts with. They come in from time to time, as I said now, based on regulatory requirements. They come in from time to time to carry out the recertification, revalidation exercises as required. So with that, we are able to, it's challenging, but with the basic things we have put on ground, and also for all our new systems, we try to do good engineering. Once you do your engineering and you select your meters right, then it reduces every other costs that we follow thereafter. So thank you. I hope this meets your expectation. Thank you.
Okay. So we'll move along to the next speaker. I'm sure this is interesting for everyone in the room. How measurement inaccuracy and oil theft complicate effective hydrocarbon accounting. So I'm going to invite Ebatarhe. I hope I didn't murder your name. Please come to take the stand. Thank you.
Good afternoon, everyone. Firstly, I want to appreciate the organizers of this conference, Dr. Sunday and his team. You all have done a great job for putting up this conference where we have the opportunity to discuss issues surrounding hydrocarbon measurement in Nigeria. That's just brief about me. Today, I've been part of this conference since its first edition online, and I'm really happy to be here again this year to discuss issues surrounding hydrocarbon measurement. I'll be discussing on how hydrocarbon accounting is complicated by measurement inaccuracies, losses / theft. So I may be using the word losses, theft, reason because theft and losses are not all losses are actually theft. So please, in case you see those words, just because also measurement inaccuracy are also losses. So when you see those things on the slides, please just don't find it strange. As we all may know, Nigeria is losing billions of US dollars annually due to illegal oil bunkering and theft. And oil losses and theft has been a major concern in Nigeria, oil and gas industry. It has affected profitability and reputation. And one of the major factors to this is measurement inaccuracy. And what is measurement inaccuracy? Is simply the discrepancy between quantity of crude oil produced and the quantity of crude oil measured. Please. So yeah, the next slide, please. Here I have a data of crude oil theft in Nigeria. Some of these figures are huge, and I have personal reservation for some of these figures that were computed, but I have to use it for this presentation. In 2021, unverifiable report from both printed and electronic media indicated that Nigeria was losing 90% of its daily produced oil to theft. In the same period, some media houses reported that these losses were in a region of 600,000 barrels of oil per day. This is huge. One other report stated we are losing 1 million barrels per day. The one that really got me interested is the one for December 15, 2022, by Naiti, that we are losing 1.6 million barrels per day. And I was wondering how much is Nigeria producing a day? NNPC also stated that we are losing about 470,000 barrels per day. And this is between January and July 2022, Nigeria lost $10 billion to this crime, which is equivalent to 4.3 trillion naira, accounting for more than 50% of Nigeria foreign reserves. Even at this discrepancy involved in these figures, one thing that is certain is that Nigeria is actually losing huge amounts of its daily production to theft. And one of the major factors in tracking these losses is measurement inaccuracy during crude oil production, transportation, and storage. Next slide, please. Significance of hydrocarbon accounting. Well, that is why we are here today. Hydrocarbon accounting simply is the tracking of oil and gas production from the tracking of oil and gas from the point of production to the point of sales. It's our cash register because it is crucial for financial reporting, resource management, reserve estimation, production optimization, operational efficiency, regulatory compliance, risk management, and loss prevention. Sorry, I would like, next slide, please. I like moving to this because these are some of the interesting facts about the presentation. Sometime around March this year, there was a publication online that stated that NPRC said approximately 40% of the volume of crude oil losses in Nigeria petroleum industry are due to measurement inaccuracy, not theft. In my own personal view, I find it impossible to see how this is even possible with the metering technology and compliance process in place in today's world. So it's really, really interesting. These MIs are mostly caused by unsuccessful meter proving, use of invalid meter factor, failure of auto sampling system. This one is interesting because I can say with facts, there are still some major IOCs in Nigeria that do not have auto sampling system in their production facility. It's very, very interesting. Some do not even do sampling. Some use theoretical BS&W. Please, back to the slide. Use of manual sampling and theoretical BS&W. Use of wrong API, non-application of volume correction factor, the use of illegal or tampered with measurement equipment such as flow meters and gauges, use of uncalibrated and faulty measurement equipment, inadequate maintenance, lack of training and supervision, because some of these operators that operate this measurement equipment do not have proper training. And sorry to say, our critical measurement point in this country is properly not monitored and supervised. And that's why we have some of these issues. What are the main sources of crude oil loss and theft in Nigeria? One is illegal bunkering, unauthorized tapping of pipelines to siphon crude oil, pipeline vandalism, smuggling, illegal exporting of crude oil without proper documentation. On this, I find it very interesting. I don't know if I'm right, because I believe for someone to export crude oil out of this country, I think we have a lot of signature, close to about 14 agencies have to sign. So when you see on the media, they said somebody's exporting crude, is exporting crude without documentation, it's surprising. Is it really possible to export crude from the terminal without proper documentation? So when I see it on the news that Nigeria is actually losing crude oil due to theft, smuggling, sometimes I say maybe it's government that is stealing its own oil. Sorry to say I'm saying this, but this is what it is, because I've been to the terminal several times to really see how this oil is being exported, and I find it that it's impossible. I say it with facts. It's impossible for someone to steal oil from the terminal, because NUPRC is here. They lock the export valve for export. So if anybody wants to steal oil, that means someone must open that valve for somebody to steal oil. Yeah, they are doing a good job, but I have to say the truth. One is community involvement and illegal refineries, pipeline failure, accidental spills, and leak. Sometimes when they say theft, a lot of the companies sometimes don't report these leaks. And if you go to NOSDRA, if you go to NOSDRA to look for this data for crude oil spill, I saw a particular one and I was surprised. 5 barrels, 10 barrels, but how can that be possible? Which is not true. Sabotage, false measurement reading, manipulating measurement device to underreport actual quantity of oil being produced. What are really the complications in hydrocarbon accounting? The data I showed earlier, in my own personal view, I believe some of those figures were computed without actually following proper hydrocarbon accounting principles and using NUPRC reconciliation and allocation methodology for theft volume computation, because NUPRC has a proper guideline you use to determine crude oil theft. And most of these reports just come up with data, maybe from even forecasted production. You are saying Nigeria is producing 1.6 million barrels per day, lost 1.6 million barrels per day. And what is Nigeria actually producing? For me, I have serious reservation for that figure. I'm sorry to mention that agency, but for me, that volume is not correct. Some of those figures were computed using deferment figures and forecasted figures that we are supposed to produce. And since we didn't produce them, they are all losses and theft. So we should always get that right, because not all these things you see on media telling you about crude oil theft are actually correct. Many of them are not correct. If you want the actual figure for crude oil theft, speak to NUPRC, they are here. They have computation of what is being produced on a daily basis in Nigeria. So if you want that figure, they will tell you. So anybody tell you any figure outside NUPRC is actually not correct. What are the complications in hydrocarbon accounting? It results in reporting and misreporting of produced crude oil, where there are measurement inaccuracy, your reports are actually not correct. It contributes to discrepancy in production reconciliation and allocation figures. It also causes discrepancy between different pipeline injectors during monthly reconciliations, because sometimes when these figures want to be reconciled, there are facilities that do not have proper measurement equipment. There are facilities that have proper measurement equipment, and they all pump their crude into one particular pipeline. That is why I said that reconciliation methodology gives you a guideline. If this man doesn't have auto sampler, Its auto sampler does not work for a particular day, there's a penalty for that. I think it's 2%, 1%. If you are using a lat unit, your lat unit is not recertified, you did not do your bi-monthly meter proving, there's a penalty. So those things are actually applied. So it actually reduces monthly allocation factor. Every hydrocarbon accountant wants to have a good allocation factor for his annual KPI. Losses and theft contribute to uncertainty, unaccounted losses, interruption to production targets. As we all know, all oil companies have production target for the year. And when you experience losses, there's likelihood that you're not going to have that production target by the end of the year. What are these implications? Next slide, please. It results to they have a financial implication because it results to financial loss for both the oil company and also government. Today, Nigeria is crying of money. We need money to do a lot of things. One of our challenges is a result of crude oil theft. Regulatory compliance. It undermines transparency, accountability, and trust in the industry. One is because today, a lot of people say NUPRC are not doing their job. It undermines whatever they are doing. But I can tell you, well, sorry, I'm not an agency man, but I can tell you that NUPRC is doing a lot, but truly they still need to do more to actually address these issues. It results to environmental challenge, most especially now we are talking about climate change. If you go to a lot of our rivers, swamp area, you see oil pollution affecting our local communities. This one is very important, reputation and investor confidence. Investor confidence may be negatively affected, leading to reduced investment and potential economic setback. At this point in time, Nigeria do not need this. And you can see from my earlier slide, I talked about the amount, the billions of dollars Nigeria lose annually. If those money are coming into the government purse, I know today we will not be where we are in this country. Next slide, please. Yeah, basically, I have an illustration for a particular pipeline network in Nigeria, which I'm not going to mention. I'm just using it for the purpose of this presentation. From the chart on my right, this data review was between 2014 and 2022. Due to high level of thefts, you can see there was reduction. The trend moved downward because of theft between 2021 and 2022, which is one of our peak year in crude oil theft. I don't know any PRC you know. You can see allocation factor dropped drastically. Then if you go to the chart on my left-hand side, two operators actually injecting into this particular pipeline. The one operator A does not have proper measurement equipment. I won't mention them, but I can tell you that's the fact. Operator B has everything in place. If you look between 2014 and 2017, there's a zigzag movement. This was due to a measurement inaccuracy within this period. And because the methodology they were using at that time was somehow funny, it favored operator A. But well done to NUPRC in 2017 when they introduced the new methodology for reconciliation and allocation. And you can see the sharp change in trajectory. The losses allocated to operator A increased drastically, and the one for operator B began to drop because they were not penalized. They have all measurement equipment in place. On the pie chart here, 7% of these losses between this period was measurement inaccuracy. 7% is huge if you want to translate it to cash. So that 40% they actually said, if you begin to put this figure together, it's actually right. So, but what can we do to address these issues? What are the way forward? Sorry, I'm walking. I just want to try and illustrate. I try to put this into three categories: the industrial measures, the regulatory measure, and the last one, collaboration and partnership. The first one, there's need for us to invest in advanced measurement technologies. We need to enhance surveillance, real-time monitoring of our system and security measures. A lot of the speakers yesterday and today have talked about technology to monitor our pipelines. We need to have that in place. There is need for training and awareness. Ensuring personnel are trained on proper measurement techniques and the importance of accurate hydrocarbon accounting. Earlier this afternoon, I was discussing with some of our colleagues on hydrocarbon accounting that there's a lot of gap between commercial team, hydrocarbon accountant, and most especially the feed operators that actually operate this measurement equipment. We need to close that gap. We need to let the man know in the feed that what you are measuring now is what translates to cash to this company. You must take it important. Today, you go to a lot of feed, many feed operator, sorry to say. Well, I was once a feed operator, so I know what we usually do at that time, out of ignorance anyway. But now, I'm at the other side. So I know what it is to actually do the right thing. One other thing we lack in this country is regular maintenance of our measurement equipment. It's only when we want to do recertification. That's when most of us try to put our measurement equipment in place. There is need for regular maintenance. On the regulatory measure, I will stick to two important ones. Two important ones here. There is need for the regulator to conduct audits and inspection of measurement system, both internally, externally, can help identify any deficiency or areas of improvement. This audit should encompass a comprehensive review of measurement equipment process, data management system to ensure that they meet quality standard and adhere to applicable regulations. Any PRC, please, this is very, very important. We need improvement on this. If you need to employ consultants, you need the support of experts, please, there is need. We need regular audits. Regular, very regular, because a lot of IOCs need to be audited. A lot of them, sorry to say, but a lot of them need to be audited. Then there's another one is all terminal operators should install latch units for each pipeline at the inlet manifold of their facility to have proper accounting for production allocation. Because when you have a latch unit on your terminal, entry of a terminal, most times it's easier to detect losses and theft because people man those latch units. And when they see dropped in volume, dropped in pressure, you can easily call your injectors. Are you still injecting into the line? You say, yes. What is your flow rate? They begin to speak. So with that, issues of losses can be minimized because then you need to intervene and call your surveillance team to check whatever that is happening. The last one is collaboration and partnership. Collaboration and partnership between industry stakeholders, government agencies, local communities is essential to combat crude oil loss and theft. Sharing information, resource can help develop comprehensive strategies and solutions. Next slide, please. What are the best practices going forward? There's need for calibration and maintenance of our measurement equipment, standardized measurement techniques, quality control and assurance, real-time monitoring and validation. This is very, very key. Qualified and trained personnel, data management and documentation. This is good for audit and traceability because where all this measurement equipment is saved on the server, anywhere you are in the world, you can access this data and actually know if anything is going wrong or what they have been doing historically is wrong. There's need for third-party verification, and we need to enhance regulatory compliance, and industry must adhere strictly to regulatory compliance. In conclusion, I would say measurement inaccuracy, oil loss / theft pose significant challenges to hydrocarbon accounting in the Nigerian oil and gas industry. Addressing this issue requires a combination of advanced technology, enhanced surveillance, training, and collaboration. By improving accuracy and transparency in hydrocarbon accounting, the industry can enhance financial stability and regulatory compliance so that people will not start saying NUPRC is not doing their job. I really want NUPRC to do their job. Thank you very much.
Thank you very much, Ebatarhe. We can feel the passion for the subject. And if I were given $1,000 for every time you called NUPRC, I'll be very rich. NUPRC are working. There's a lot of work to be done, and we recognize their efforts. And I think that it's a call to action for everyone. It's a collaborative effort that's required to, overcome the challenges that we face in the industry. So I'm going to invite now Engineer Gbolahan Lawal. He's the MD CEO, GIL Automations Limited, and he's going to be speaking about digital offerings of smart stations in multi-phase measurement.
Good afternoon, everybody. Please, can I have my slide on the table? I think I'll just go with, no, not this one. I'll just go with the last speaker. I've learned a lot from him. First, it's okay to walk away from the podium. And then also it's okay to call out your regulator. So I'll also be calling names. But I think it was a frank presentation, and it actually speaks to the volume of the presentation I'm about to have. So I will be talking today about leak detection systems. I'll be talking about, well, I didn't call it theft detection, but usually most of our customers that do leak detection, it's also to capture losses. So I will be talking from best practice implementation in Niger Delta. I mean, what I mean by that is that leak detection technology, it's a proven technology. It's just like everywhere in the world. But we find out that most times when it's done in Nigeria, sometimes it just doesn't work. It doesn't solve the problem. It doesn't outlast the purpose. So we will be sharing from the field on, what we have seen that has worked, what are best practices. The presentation, please. So I will just go over. I will start by introducing myself. You already, some of you know me already. I've been, okay, yeah. So I will be speaking again on best recommended practices specific to Niger Delta. So some of them may not, while they will be compliant to, the recommended practices of API, some of them may just be our own grown based on the physical features that we see that are peculiar to our region. Next page, please. So I would talk about the company. I'll talk about leak detection systems, typical applications, recommended best practices and regulation and standard. And then we'll open the floor for questions. Next, please. So about me, like most of you, in my idle time, I think about uncertainty. How can we reduce? That's a lie. I'm an instrument engineer. I've been practicing for about 20 years. I started out, installing SCADA, wellhead instrumentation, hooking up pressure downhole gauge, digitizing wellhead production on a well-by-well basis. I did, quite about 100 of them or more. Then we started gill automation specifically because, it's one thing for you to have this technology, but making them to solve the problem you intend to have, it's a whole different game. And, it applies to how you localize it, how you deploy, and then the people you have to back it up post-installation. So, I've been involved, volunteered as a senior member of the International Self-Automation. I was the past chair of ISA in Nigeria, and so on and so forth. So let's go to the next page. I also am an OPMer with Harvard Business School. So gill automation, we do instrumentation, we do flow measurement, we do control. We've been doing this for about 15 years. We try to, our focus recently has been on digitization. So for example, your LAX unit. whatever it is that you still send your operator to go physically to that equipment or your flow meter to go and measure, how do you make sure that that data comes to you? Because from a total cost of ownership, this is a big, big differentiator. So, for example, the biggest difference on a critical production line between a pressure gauge and a pressure transmitter, and the initial stage, it may look very cheap to just go with a pressure gauge. But if you look at the total cost of and the risk and the safety of sending a guy out there every time to go pick the parameters and then come back. In some cases, some people even go by chopper. One chopper ride already bought, a transmitter that can send that data to you. So leak detection system is also an enhancement to that, which is that it helps you to, one of the test cases we've had, you can discover leak as early as 30 seconds on the 30-kilometer line. It can pinpoint to you that this particular point on your line is where this leak is coming from. So it's one thing for you to check how much are you injecting over there on radio and say, how do you copy over? And then the other guy too on the other side. But you want to make sure that you can use the existing infrastructure that you have. Most of those lines already have flow meters, they have pressure transmitters, they have temperature transmitters. How do you use that data to make intelligent decisions? And how do you make that visible to your management and to your leadership? I think having that, is one step of first optimizing your surveillance team, and then also knowing what to do next with your intelligent data. So we have, these are some just picture story. We have a base in Lagos, in Port Harcourt. We manufacture electrical switchgear control systems in country. We built a GINA ICSS system. We're the first local company that will do that. And the GINA FPSO is producing today. Next slide, please. In our Lagos, we build switchgear. We have a training center. We have a project management center. And in our Port Harcourt base, we have our field service team. We have field service crew that we do. Thanks to some of our customers, we do on-site, inspection, maintenance of flow meters, maintenance of LACT units. We have our own small volume prover, which we use as a primary or as a master measure to be able to prove offshore and onshore and so on and so forth. Then we also have a mobile safety valve test bench for interventions. Next slide, please. So as a company, like I said, beyond having technology, it is having those technologies work for you locally. And that has been the vision of the company. Locally, we are technical partners for Krone, and most of you know Krone from ultrasonic meters, Coriolis meters, wet gas meters. We work with Elstar. Elstar is the GCs and the analyzers and so on and so forth. We work with Weatherford for the water cut meters and the multi-phase meters. And we work with Foreman. Foreman is for the helicaturbine meters. And then also we work with IMI Critical for the controls valves and emergency shutdown. For example, if you have a loss, how do you mitigate that? Or sorry, if you have theft, how do you mitigate that? The amount of losses that you have, how do you automatically control the valve, the shutdown valve, that makes sure that you don't lose as much beyond the leakage, and then you don't pollute the environment or get the nosedive people behind you. So the next page, please. I'd mentioned again, just the local service capabilities that we have on the field services, which is metering system, annual proving, servicing existing meters. We have our own master meters that we rent out and some that we use to benchmark. We have our small volume provers and so on. Next slide, please. So why leak detection? The question begs for everybody knows why we have to do it. If you call it leak detection, yes, you might think it's a nice to have. But if you call it theft detection, it tells the story. If you spend all the money investing, drilling, completing, and so on and so forth, and you have your production, and then somebody else has idea with, who should have custody of that, So it's the question does not, but beyond that, also safety, also environmental issues, and so on and so forth. And like, for every problem in life, there's no one answer to it. From a technology or a technical standpoint, there are two ways. We call it the continuous and the non-continuous measurement. For example, to monitor leak or theft on your line, you can fly a chopper every so often and go and physically check. It's non-continuous, but at that point, at least you can do it. You can, some use smart pigging, because when you pig your line, it also helps you to know if there's any, especially on the internal diameters of your line, and it helps you know, the gradient and so on and so forth. So some use their pigging data also as part of their leak detection, but it's not continuous. You only do that when you're pigging. And then some send tracking dogs, some would hire local enforcers to say, if anybody do anyhow here, let them see anyhow. Well, and then there's the continuous way, which is external can be that you put fiber optic on the line. There are proven technologies where if you layer fiber optic on the critical part on the line, you can use acoustic systems, which is, you look at the vibration on the line, and then you can now measure differential in those vibrations and use that as data. You can use sensor hoses. Some actually, for shorter lines, you do video monitoring. I mean, just put in a CCTV camera between this end and this end. And if you cover everything, and then you can track exceptions, just like they monitor airports today. But again, it just tells you that, if there are, if it's something of value goes into a particular line or goes from one point to the other, the least you can do is make sure that, wherever you send it to is where it ends up in. And then there are internal systems. One is maybe pressure point analysis, which is, officer, how much did you push on that side? What's your flow rate? You compare with your flow rate here, it's definitely, this flow rate is not adding up. And the losses considering on this line with historical value, then you can trigger. You can use a mass balancing method, which is you check the volume before and the volume after. But all of these are static. And then there's the last one, which is backed up by API, which is the real-time transient modeling, which is that it tries to digitize the parameters that make up the line. Can I have the next slide? It tries to digitize the parameters that make up the line. So on a typical line, you have your flow meter, you have your pressure transmitter, you have your temperature transmitter, you have your line with the length, known ID, known OD. You try to virtualize that, benchmark that with what you have and your last data, and then you now model it with, over time, this should be the losses or this is the tolerances that you should have. You also model the parameters of those data. So based on those real-time data that you're getting from your flow meter and your pressure transmitter and temperature transmitter, you can now compute an algorithm and you can almost make a prediction to say, definitely there's a leak on this line. Because the only thing worse than having a leak detection system is to have a lot of false alarm. 2 a.m. in the morning, they say, there's a leak on this line, and then you mobilize JTF and all of that. And eventually you get there and it's a false alarm. It's just a bird that flew through that line, or, most times it's not false alarm, but, the last thing you want is to get the inconvenience of having a false alarm. Okay, let's have the next slide. So typical application of leak detection system would be, if you have independent availability framework, for example, like my colleague that spoke earlier, if you have two operators, imaginary fields flowing into one particular line, this is also why we have custody. When some customers talk to us about custody transfer, it's almost like, first, of course, is driven by compliance. Second is driven because you also want to know how much you're producing. But sometimes I have to prove it that this person has been producing water. Yes, he wants me to share in the losses. So it's almost like, I want my generator to be bigger than my neighbors. But it's a valid point to make sure that if you have multiple people producing into a critical line, that you can independently allocate. And that's one more layer. For example, somewhere like a subsea pipeline, if you want to do physical intervention, how are you going to physically even monitor if there's a leakage on the pipeline if you do not have an electronic way that uses current data to be able to provide it? Then, theft detection on major trunk lines is one thing to say there was a theft. If you have not noticed, when you go in during the daytime, I say there was a theft on this line. Everybody will swear to God that it happened in the next village. Because every community has the GM global MOU, right? So you're all meant to be stakeholders and even currently with the current acts. But then how do you now make sure that you have data to pinpoint that it happened at this particular coordinates, not more than plus or minus 1 meter from this particular point, and then you can also now, do your surveillance. So then also, you use it also for tightness monitoring. So it's not just theft. Sometimes the pipeline ruptures. But what if you could know the pipeline that will rupture in the next 1 or 2 weeks based on the ID parameters and the data that you're getting? Because if you're seeing unnecessary spike If you're seeing unnecessary pressure increase, it's a signal of what is happening within the internal. What if you could do your pigging before then? Next slide, please. So global standards, there's the API RP 1130, which covers pipeline monitoring for liquids. There's API 1149, which deals with variable uncertainties in pipelines. And then there is the API 1175. And then also there are individual company standards, like Shell has a DEP 31406011 gen. That pretty much all they say is that this is the minimum requirement, and these are the standards and recommended practices. Some of these are one of the things I've mentioned earlier, and I'll discuss more as we move forward. Next slide, please. So, like time is of great essence. It's one thing for you to have a leak. If you look at it from a safety standpoint on a 24-inch line, if you have a very small leak and you're losing production, first there's the economic loss, but also the amount of crude that you're going to pump into the environment, can be reduced or mitigated drastically by how accurate, if your surveillance people know exactly where to go, not starting from this place and then cutting the bush to now find out where it's gushing, or tracing it with physical parameters like where is the fire or where is it smelling. You get what I'm trying to say in the case of gas. So the technology that, with ERTTM, which is compliant with API RP 1175, you can get as early, it takes within 30 seconds, you can localize a leak up to 0.5% accuracy, which is fair enough. That means, it's within a very short distance. Next slide, please. Next slide. So the factors to consider in leak detection system is your existing instruments, your data acquisition system, your flow meters, because again, you're going to be running your analytics based on the integrity of those data. So if, like my colleague said, if your flow meter is not well maintained, if there's wax already along everywhere, and if you are just using it only when NUPRS is coming for your annual proving or compliance, then if you put garbage into the system, it's going to give you garbage at the end of the day. So you need to check the calibration and uncertainty parameters that are allowable within tolerance of your instruments, especially for your flow meter, pressure transmitters, and temperature transmitter. Then also you look at ease of this, deployment versus host community concerns. We've seen, and I will give this example that, when I started out going into the field and we were deploying wellhead instrumentation on wellhead SCADA, it will give you all your parameters, your tubing, your pressure downhole gauge, flow line, and all of that. And, we wanted more system. We wanted a situation where if you see a parameter that is not, you should be able to at least, if the weather was not good, you should be able to pick up some data and store it on the system. Anyways, we needed more power on the well site. So somebody suggested, let's put solar panel. I mean, solar panel is in the sun and everything. But you know what? Eventually, when our harvesters came to harvest the solar panel, they were not as patient to, bypass the system, do it safely and all of that. They just pulled tubing along with the solar panel. And so you are trying to solve a problem, but you're creating a bigger problem. And in some cases, you deploy technologies that, you actually paint it in the same color of the tree. So if you're looking at it from a distance, it's just another pipe. But meanwhile, you have your data acquisition. So again, we've seen that happen a lot of times where, a technology always works everywhere else in the world, but when it comes to Nigeria, it just, it grows a new character, a new identity by itself. So you have to consider the ease of deployment. Okay. So then also data access. Some want the data to be independent, which is, you're talking about your production data. You're talking about how much is being flown through your lines. You want to localize it. Some want it integrated. You want the boss in Lagos. You want all your shareholders to also see that value and be able to integrate. Then alarm management, which is command and control after the detection. Next slide, please. So this is a typical data acquisition system from the line. Like I said, pressure, temperature, flow. You flow into a central controller, and then you put it into your control center. Some even tie that into your existing control system, but some just keep it independent and say, we'd rather get a daily report because of the integrity or because of the sensitivity of the data that comes through it. The next slide. So then also, like I said, there are situations where if you have high consequence area. For example, your largest export line that is filled with fully processed crude. There's nothing raw. You've done everything in your fluid that pumps out. At that area, you should also include a shutdown valve so that if there's any bypass, you should be able to at least stop the losses. And these are just best practices. So the next slide, please. Then, of course, this is just talking about all the other ones. You can use radio, you can use existing mobile network. We can use the 428 megahertz that is being used, the ISM band, and so on and so forth. Next slide, just to round up that, local deployment competence can make or mar the benefits of a leak detection system. Leak detection system is a norm in almost every other project deployed in the world. So thefts and all of these things that we talk about here, at least you want to isolate that it is not due to losses that is or something that technology can solve or that is solved everywhere else. But how you deploy it locally is what has really made a big difference so far. The second thing is that in addition to cost consideration, you should always consider this integrity of your existing system. If your flow meters, your pressure and your temperature are not in good condition, or they don't have the right, they are not within tolerance, then eventually what you're going to have in your system is also going to be an outcome of that. Then, my own practice is test before you drive. For most of customers, you should insist on no cure, no pay. So if you're telling me you want to detect leak, I should be able to simulate a leak. I should be able to tap my line and show me the impact that this is spiking. Not that we deploy the old technology and every time you say, you didn't tell us that the pipeline was buried underwater in the swamp. We thought it was surface. So you should have a no cure, no pay, or you should test drive before you have it. Just like we do when you go buy a new car or any other high value item. Then cybersecurity is very, very important. And post-theft analysis are serious consideration, which is, okay, there's an alarm, there's a leak. What do you do? So you need to have a mitigation in place. You need to have a surveillance in place from a safety standpoint and from an economic standpoint. And then also your cadre of doing it. And then lastly, what you can't measure, you can't improve it. Beyond all the talking about, the impact of all of this, it is that these losses are actual money that operators are losing. So the best day for you to start your leak detection journey or to start asking those questions to your operators, to your measurement team, and to your managers is now. Because eventually, when things go wrong in measurement, they look at you, not look up to you. When you get fined by NUPRC, this is the metering team that gets called up first. And you will explain because there's no evidence. Then the last page. So I think that's about it. Last slide. So that's it. So I'll be around if you have any question whatsoever. But I think in all of this is just to say that some of the problems we have, technology solves them. But how we deploy sometimes is more important than the actual technology itself. Thank you.
Thank you, Engineer Bolaho. Technology is definitely critical to overcome the challenges we have in the industry. I'll quickly call up our last speaker, Engineer Sopulu Unachukwu. He's going to talk about integrated fiscal metering for revenue optimization and gas in oil and gas facilities.
Okay. Good afternoon, ladies and gentlemen. Unfortunately, of the time, so I'll try as much as I can to summarize. So, Chairman, I would like to stand on the existing protocol. Okay. I don't know if I can get my slide. So, but before then, before the slide comes up, so I don't take even more time. We've had very great discussions. We've highlighted most of the issues. In fact, my client, I'm always happy when whenever he's presenting, just like last year, I would have taken his presentation from mine. He did a good job outlining some of those salient issues around fiscal metering challenges. So I'll probably skip that part. My focus is mostly around a way forward some of the things, looking at the bigger picture. Okay, so just as an introduction, my name is Engineer Sopulu. I work with Trex. Can skip the profile because of time. So, like I said, we're going to look at way forward, some technology propositions. I won't go into the deep academic stuff because some of the speakers have mentioned that, just like the pipeline leak detection, some of those technology propositions, we've looked at it. So I'll be looking a bit at the bigger picture. Thank you. Next slide. Okay, so like my former colleague mentioned, they've looked at the issues, but as a service provider in Nigerian oil and gas industry, especially within the upstream, we've seen quite a lot. Some of those challenges are peculiar to various operators, right? Some are facing the leak issue, theft issues, the metering inaccuracy challenges. So, but there are some fundamental things that we've seen working for several operators within the industry. A lot of them has been highlighted. I will start from the engineering and product selection. This is usually where the flaws originate from. Most times, we don't have, I mean, there are companies that has the local capacity service providers, but in some cases, the production companies or the end user don't engage them at the early stages. So metering is a fairly, the issue wasn't a front burner, let's say 5-10 years ago. So, but it surprises me when even at this time, some of these companies still think that's the conventional type of service where it's easy for them to scope it and then give you a recommendation of what they want you to do. Is always what we faced a lot of times with some operators and end users. So the engineering is key. The reason why you have to bring in these expert service providers early is that we've seen multiple technologies, we've seen different technologies, and everybody, the OEMs will always tell you that their technology works, right? So, but we have worked around most of those technologies. We can let you know what the best application for you and what the NUPRC guideline says, because it's usually our guiding principle in all the things we do. So that's the origin of the issues, the capacity to engineer or spec the right solution for most of the customers. So, I don't want to go too deep into it. So I'll try to just give the highlight of it. I'll give an example for inline custody transfer and flare metering for offshore production facilities, especially flare, because of the NUPRC mandates and penalties and stuff. So there are a lot of companies are in a hurry to deploy so that they stop getting fines. So we've noticed that most of these facilities were not initially or originally designed for flare measurements. So you have a scenario where you don't have enough stretch run to install the meters. Maybe they've commingled some moisture into the flare, making it difficult to use the right application. So some of these issues, just an example, some of these issues are the reasons why you have to have the right manpower being able to engineer some of these solutions, because they are usually unique as applies to different facilities. So I'll go beyond the engineering. So the next one is, no, you can go up. They are still within. I'm summarizing, or I'm not following the slide. So another issue is lack of sufficient process information for some of those specification and engineering. In fact, most, just like my colleague said, there's usually not enough data to even, you ask some companies to give you their gas composition, they haven't sampled for a very long time. So you end up doing some point assumptions. At the end of the day, you see that they have liquid carryover in their flare, or they have almost a multi-phase flow where you are trying to meter liquid or you are trying to meter gas. So I also plead with NUPRC to help drive the compliance, especially for sampling. So it makes it easy to have the process data really available for some of these engineering. Okay. So the other part is we have issues with the remote data gathering, the manual data gathering around most of the facilities. So I'll start this way. Looking at the metering holistically, usually we've discussed the issues, but I noticed that the accounting is now done in silos. What I mean in silos is you have the different points of measurement that typically you should have. You're supposed to know what you're producing from the wellhead to your flare, to your custody transfer, whether gas or liquid, in some cases at your buffer tank or storage facility. So what we do now, most of the experience we've had as service provider is the operator does a contract for, let's say, custody transfer, because that's usually their priority, because I mean, you have to measure, if you have to know what you are selling, right? So they don't know, some of them still do the manual mass balancing around the phase separators at the time the production comes from the different wellheads. Okay, so and the custody transfer point could be at some distance, not necessarily within the flow station. They also have another accounting at the gas flow point. They have another one at the flare. So what happens is this: they are not able to, properly reconcile what they're doing. Their interests are mostly just around what they're selling the third party. So in most of these facilities, especially within the onshore location, many years ago, they were mostly owned by one big giant IOC or the other, right? So, but now you notice that they are now broken into different clusters for small companies, smaller companies, marginal field operators. So the design wasn't there originally to put in some of those metering handshakes and interfaces. So I think now we have to now start rethinking the entire hydrocarbon accounting concept. We can't continue seeing it as a new thing because it has become the main issue, right? If you are going to have auditors audit your accounting system, your finance, you have independent crude oil surveyors, or people that do alternative crude evacuation, people that do exports, try to check the volume of what you are selling. Why can't you have a sort of hydrocarbon accounting contractor that will have a sort of single source or point responsibility, thinking through from the measurements from the wellhead, using, like, next slide, let's leave this. So my proposition is a sort of a consolidated contracting strategy. It's actually a recommendation to the production companies and also to NUPRC. It kind of helps. I'll talk about the benefits. So you could have a single source responsibility. If you're able to engage a competent service provider that understands holistic metering as they were, so your job is to invest, drill wells, produce crude and sell it. Your job is not to sit down and start accounting for hydrocarbon. Okay, so you need to, if you're going to have O&M contracts for things like calibration, PSV valves, and all whatnot, you could actually have a similar system for your hydrocarbon accounting. So we need to take it a bit step further. So typically, you meter at the wellhead. You can use the multi-phase flow meters. Where companies have deployed it, Trexam has deployed it onshore, still skidded, normal inline MPFMs, and commissioned it functional. You could, instead of, I understand a lot of them operate based on cash calls because of the marginal field operator, they don't have a lot of funding. You could also have inline meters for custody transfer. The technology is already there. For flare gas metering is also where we've encountered a lot of issues, from the right technology selection Some customers want to use normal process gas meters to meter flare. You know, it comes back to the issue of the engineering. So they want to tell you, of course, this is what we want, right? At the end of the day, it won't work because of mostly around the pressure. Flare is usually at almost close to atmospheric pressure. So most times it doesn't work. And then the sizing, the calculations, the engineering that has to go into it to ensure that there is also the repeatability, you make sure that you get the result that you need. Sometimes it's not there. There is also more advanced technologies that for operators that help optimize even your flare. They'll call it the Flare IQ, is a software, is a econometric software, but there's really not much time to dwell on it. So it helps you also manage and automatically maintain even your flare system. Okay. The other one that is not talked about enough is the measurement at the storage facility. So we're always talking about the points of handshake, custody transfer, but we'll have buffer tanks, we'll have very large tanks that we need to consistently measure. I know some facilities where they still do dipping for very large tanks in upstream, unfortunately. Apart from the safety risk, you can't get the accuracy that you want. Okay, so you can have automatic tank gauging systems, not just to meter and send you data. You can actually measure interfaces, the crude oil and water interface within the tank. So you can have those solutions. So of course, the leak detection, which my colleague, the previous speaker, has spoken about. And then very importantly, most of our field instruments, from our experience, when we go to the field, are usually not automated. They are either obsolete or not functional. So you can't have the systems integration, the digitization, the automation we are talking about if you still have very manual and obsolete field instrumentation. At least is a good place to start. Okay? Of course, the integration of the entire metering system. So next slide. So what I'm saying is we need to just go to the next slide. There won't be time to explain this diagram, but is looking at a holistic metering, thinking in a bigger way around metering across the entire facility, not just in silos. You meter your flare, you come back tomorrow, you meter your do an MPFM, you come back next day, you do. So you have to be thinking across the entire facility. There are very quick wins that you could get if you think in that direction. You could have a single point responsibility for hydrocarbon accounting. I've mentioned that before. You can sit back and allow someone really help you and account for your production. So you also have adequate checks and balances. If you're able to meter from the wellhead to the storage, to the, I mean, it's like the normal mass balance we did in school, right? So you'll be able to know where is the leak or the losses or whatever coming from, even before it happens, instead of detecting it when it happens, okay? So also, you're able to grow Nigerian content value because if you have companies specializing in hydrocarbon accounting, they will be forced to get trainings for their personnel. Even if there are OEMs that will be involved, they will have to give them the right trainings and have the equipment and facilities in place. Of course, minimal reconciliation issues, and you could easily identify the losses when they occur, okay? And then, of course, you have your increased stakeholder confidence because leveraging the telemetry system, if you upgrade your field instrumentation, you'll be able to visualize your data either remotely, you reduce manual inputs that normally leads to errors. So this is the end of the presentation, and we'll be happy to take all your questions. Thank you very much.
Thank you very, very much. So we're out of time, but we'll try and squeeze in 2 questions from the audience. I don't know if we can quickly take that. We have 3 hands up, so we'll take.
Chairman, it looks like we still have one more last session. So we can only take 1 question with your permission.
Wow.
Okay. So who is the lucky fellow?
Put his at the back. He put his hand up.
Well,
first.
I might have to ask the top chairman if we can take how many? 2 or 3? 2. Okay. So 1. Somebody was raising his hand
There's
somewhere.
Back.
Okay. 2.
There was someone that
Hmm. I know this is very engaging. Yeah. So, okay, let's take all of the questions together, and then, Chair, we'll wrap up this session in 5 minutes. So briefly, no this stuff, just straight.
Well, but I'm used to doing Anyways,
Okay.
mine is not a question, but because, like the chairman said, if the number of times NUPRC was mentioned, if she was paid $1,000, she would have been a millionaire in dollars. So I happen to be of the NUPRC, and I needed to just put some things in perspective, right? The industry that we run is a rule-based industry. Rule-based in the sense that we are guided, first of all, by the law, the act. Currently is the PIA, right? And then we have the regulations pursuant to the act. And then we have the subsidiary guidelines, in line with the regulations. The issues you've raised, and I'm talking generally, right? The issues that each of you speakers had raised, germane, quite germane. But I need to mention that because we are a rule-based industry, we run a rule-based industry, and the regulators are to abide by the rules of the game, of the industry. So what the regulator does, it's actually in line with the regulation, right? And the laws of the land. So when it comes to particularly the mention of one of the recommendations that I saw, that we should do more of auditing of the metering system, right? I just want to say, now there is already established guidelines for management of those kind of processes. Meters, for instance, there are quarterly validation, there is annual recertification of metering systems. And that is what the rules require, right? Now, the commission or even the NDPRA or any regulator would not set aside what is in the law and simply because it looks interesting or nice, because there are costs associated to every activity. And before each of the regulations and guidelines are actually brought into being, there is the consultative forum, which the PIA has enabled, right? Where the industry come and actually discuss and say, no, we cannot do this. Because if you do the cost-benefit analysis, regulatory cost analysis, then it may not worth the while, right? And so the industry now agrees with the regulator on what should be the standard that has to be followed. Now, when that standard is established, the regulator enforces those standards. So I just want to that's why it's a general comment that just to highlight what guides what the regulator does. It's not emotional, but it is the law, the guidelines that already agreed, that is the way we need to run our industry in our country. Thank you.
All right, we'll take you quickly.
Good afternoon once again. My name is Stephen Owotemu from Heritage. My question is for the man from GEO. Recently, there has been incidences of vandalism of flow lines from Warhead, and they've actually increased tremendously in recent time, compared to any other time. So my question is, what is the suitability of this your leak detection in these areas? Then for the lady in green, you talked about the use of chemicals to take care of your pipeline and all that. So my question is, based on your experience, what were the parameters that you measured to discover that what you needed to do to free your pipeline was chemical application? Was it that you had loss, you lost complete, your flow rate dropped to a point where, it became a concern and all that? I just want to know.
Okay, I saw my friend here nodding his head. But Chair, I'm afraid that that's all we can take. So we're wrapping up the session in 5 minutes. My apologies to those who we can attend to. Thank you.
We can't take their questions. So please, Engineer Gwalaho, thank you.
So because of time also, I mean, I'll be more than happy to explain the technicalities and all that. But in principle, as long as you can measure, you can virtualize. So if you have if it's a commingled flow, if you have a multi-phase meter existing, yes, the leak detection system can work. The theft detection system can work. And, you know, it works almost everywhere else in the world. But we can talk about the specifics and the details and then how to also mitigate in the future. Thanks.
All right, Yewande, please.
We discovered that we had a very low flow rate initially. We opted for the mechanical means of mitigating the problem, and the pigging operation was performed, but that was able to solve the problem temporarily. But over time, when wax began to accumulate again, we needed to look for a sustainable, I mentioned sustainable and economic efficient method of mitigation, and the chemical treatment was just the perfect thing to do at that point.
Thank you very much to everyone, to our speakers. Thank you for all you had to unpack in the very short time. And thank you to the audience for giving us your attention.